Howdy there, Mr. Sutton here, bringing you the IM3 Chapter 1, Quiz 2 Extra Practice Number 1 solutions on solving systems of equations, especially with the elimination method and word problems. This one goes with a puzzle. Let me show you the puzzle. So here's the puzzle for this particular solution set. We have a riddle. What kind of shoes does a frog wear? And the idea is we have these 12 different systems of equations. They want us to solve each of these using the addition method, with the caveat that you might have to first multiply both sides of an equation by -1, and then find your answer below down here, cross out the letter that's above it, and then when we're done, the letters that remain will spell out the answer. All right, let's get to it. For this one, we're trying to solve this system of equations. So I notice that I have a -2y and a positive 2y. So if I just add these together right away, I am going to get something to cancel out. Let me just rewrite this one underneath my second equation. Add these two together. That cancels out my y's. X plus 5x is going to give me 6x. And then 8 plus 4, that's going to give me 12. So I have 6x equals 12. Dividing both sides by 6, we end up with x equals 2. And then I can plug the 2 back in to solve for y. I'm just going to use this equation over here because I've got some room. So I've got 5 times 2 minus 2y equals 4. So that's 10 minus 2y equals 4. Subtracting 10 from both sides, 4 minus 10 gives us -6 over on the right side. And then dividing both sides by -2, we have y equals 3. So that's the point 2, 3, if I put those in order. And then looking down below to see what that goes with, I see 2, 3 right here. So I'm going to cross out the s and go on to the next problem. For this system of equations, I see right away that I have a -3x and a positive 3x. Those are going to cancel if I just add these together right off the bat. So let me do that. So let me move this one down below the first one. It doesn't really matter which way we go here. And then if I add these together and cancel that out, we end up with 2y plus -4y. That's -2y. And then 11 plus -19 is -8. Dividing both sides by -2, that means we have y equals 4. And now if I plug that back in over here, let me figure out the value of x. So I have 3x minus 4 times 4 equals -19. So 3x minus 16 then. Adding 16 to both sides, -19 plus 16 is -3. And then I have 3x equals -3, so dividing by 3 gives me x equals -1. That means -1, 4 is the answer to this one. And if I look down below, let's see here, -1, 4, where is that? That's right here, right below the e, so we cross off the e. For this system of equations, I notice that I have a y and a y. So that's not so bad, although these will not cancel right off the bat when I add these equations together. If I multiply one of these equations by -1, then I'll have a -y to cancel out a positive y. So given the choice, I'm just going to multiply this second equation by -1. It looks like there's a little bit less going on than in this first equation. So doing that and putting my answer down below the first equation, I've got -x, -y, and -3. Just make sure you multiply all of those by -1. Next, if I add these two equations together, the y's are going to cancel. I've got 3x plus -x, that's 2x. And then 13 plus -3 gives me 10. Dividing by 2 to get x by itself, I end up with 5 for that value. And now I can plug the x value 5 back in over here, because I've got some room here. So I've got 5 plus y equals 3. Subtracting that 5 from both sides, we end up with y equals -2. So that's the point 5, -2 that I'm going to be looking for. And looking down here, let's see, 5, -2, 5, -2, 5, there it is, right below the I. Boom. For this system of equations, If I want to add these together and cancel things out, I notice that nothing's going to cancel, but I'm coming pretty close with this negative 2y and negative 2y in each equation. If I multiply one of these equations by negative 1, like they suggest, then I will have a positive 2y that will cancel a negative 2y. So I'm going to multiply this second equation by negative 1. I just have to pick one and go with it. So if I do that, that gives me negative x. Now this is going to be positive 2y. And that's going to equal positive 5 on the other side. Now I can add these two equations together, and those two y's are going to cancel. 6x plus negative x is also going to give me 5x, and then 10 plus 5 is 15. Next, dividing by 5 to get x by itself, we have x equals 3, and I can now plug the 3 in over here, or I could use this other equation here, it doesn't really matter, to get the y value. So we have 3 minus 2y equals negative 5. Subtracting 3 from both sides, negative 5 minus 3 is negative 8. And now to get y by itself, I have to divide by negative 2. Negative 8 divided by negative 2 gives me y equals 4. So that's the point 3, 4. Looking through here, I see that right here under the r, so I'm going to cancel that one out. For this system of equations, if I use the addition method and add these together, nothing's going to cancel yet. But if I multiply one of these equations by negative 1, I would have a negative 5x and a positive 5x. I'm going to multiply the second equation here by negative 1. I've got to choose one of them. So that'll give me negative 5x here, and also this will be now a positive 3y, and that's going to equal a negative 14. So I have to negate everything. Adding these together, 5x's cancel, y plus 3y is 4y, and 2 plus negative 14 gives me negative 12. Dividing by 4 to get y, I have y equals negative 3. And then plugging that back in, I'll plug it in over here. We have 5x minus 3 times negative 3. Now I can solve for the x value here. Negative 3 times negative 3 is positive 9. Subtract 9 from both sides. 14 minus 9 is 5. And that's convenient because if I divide both sides by 5 now, I get x equals 1. So that's the point 1, comma, negative 3. Looking down below, it looks like I have 1, negative 3 over here at the very end with r, so I'll cross that off and move on to the next question. This system of equations is a little bit tricky if you're trying to use the addition method. If you add these equations together, the 4y's are going to cancel right off the bat because we have a negative versus a positive. However, we don't have these in standard form. So I'm going to end up with some x's on the left side, some x's on the right side. It's going to be kind of annoying. So I'm going to start by turning this second equation into standard form, moving the x over to the left side. And I know these equations are going to cancel out my y's when I add them, so I'm just going to rewrite this new equation underneath over here. So subtracting x over to the left, I have a negative x. I still have a 4y. That's now going to become plus 4y if I write it there. And then I still have a negative 2 on the right side of the equal sign, so I'm going to write equals negative 2. Now I can add these together. That cancels out my 4y's. 7x plus negative x is 6x. And then negative 10 plus negative 2 gives me negative 12. If I want to get x, I need to divide by 6, so x equals negative 2. And then plugging that back in over here, we have 4y equals negative 2 minus 2, which is negative 4 over there. And now if I divide by 4, we have y equals negative 1. So this is the point negative 2 comma negative 1. And it looks like that is right here underneath the d, so d goes away. For this system of equations, I notice right away that the first equation is not in standard form. So if I'm going to use the addition method, the elimination method, I need to get it so this y is over on the left side. To do that, I can add 9y over to the left. So I have x plus 9y equals 5 for this one. And I notice now that if I add these together, although everything is lined up, 9y and 9y is not quite going to cancel. I need to multiply one of these by negative 1 to get a negative 9y. So I'm going to just take the equation I just rearranged and multiply that by negative 1. So I have negative x minus 9y equals negative 5, if I negate all of those at once. Adding these two equations together now, we cancel out those 9y's. 4x plus negative x, that'll be 3x. And then negative 7 and negative 5 adds up to negative 12. Dividing by 3, we end up with x equals negative 4. And now if I want y, I have to plug this back in. And I'll just plug it into the x over here because I've got some room down here. So that's negative 4 plus 9y equals 5. Add the 4 over to the other side to get 9y by itself. And if 9y equals 9, that means that y is just going to be 1, which gives us the point negative 4, comma 1. Negative 4, comma 1 is actually right down here under the a, so we'll cross that off, and we'll head on to the next one. Moving ahead on this one, it looks like we now have not one, but two equations that are not in standard form. They're not even the right kind of not in standard form. Like one, we've got the x on the left, the other's got the y on the left. So I'm going to start by putting all the letters on the left side, numbers on the right side. So I did my second equation first when I rearranged. I need to move the 3x over to the left, so I'll just subtract it to do that. So we'll have negative 3x plus 2y equals 3. And this other equation now, I want to move my y over to the left side as well. Now I notice right away before I even do that this positive 3x and this negative 3x are going to cancel when I add those together. So I'm just going to put my new equation underneath here. I'm going to rearrange it and move it at the same time. So moving it over there, subtracting 5y from both sides, we have 3x minus 5y equals negative 9. Now this is a nice coincidence here. If I add these equations together, the negative and the positive 3x are canceling. Next we have 2y plus negative 5y, which is negative 3y. And 3 plus negative 9 gives us negative 6. Dividing both sides by negative 3, we have y equals 2. Plugging that 2 back in over here, doesn't really matter whether it's in standard form or not. We have 3x equals 5 times 2 minus 9. So 5 times 2 is 10. And if I subtract 9 from that, obviously I have 1. Dividing both sides by 3, we end up with the interesting answer of x equals 1/3. So this is our first fractional answer on this puzzle. So I have the point 1/3 comma 2 now as an answer that I'm looking for. Well, that should be easy enough to spot. Not too many 1/3s out there. Here's a 1/3. Here's a 2 that goes with it. So that's going to be L. I'll cross that off, and I will continue. For this system of equations, everything is in standard form, but if I add these together right away, these two y's are not going to cancel. Neither is the x and the 4x. However, if I multiply one of these equations by negative 1, I can get something to cancel. Let me multiply this first equation by negative 1. So that's going to be negative x, negative 2y, which is what we were after with our step there, and then negative 2 is positive 2. Adding those together, we cancel out those two y's. That's really what we wanted to do. 4x plus negative x is 3x. Negative 17 plus 2 is negative 15. And now if I divide by 3, I get x equals negative 5. Plugging that back in over here in this first equation, we're going to end up with negative 5 plus 2y equals negative 2. Add the 5 over to the other side. That'll be a 3. And we might be thinking we did something wrong at this point because this is not going to be a whole number. A y with the 2 divided everywhere is going to be y equals 3/2. So if that's the answer, then we should be looking for negative 5 comma 3/2. Is that one of the answers down here? Well, let's see. Negative 5. There's a negative 5. Wrong number, though. Keep going here. Oh, negative 5, 3/2. There it is. Okay. So that means we have n that we can cross off, and it's on to the next. Trying to solve this system of equations, I notice that my second equation is not in standard form. Let me subtract 6x from both sides to get all my variables on the left side. So now we have negative 6x minus y equals just 4. If I add these equations together now, I'm not canceling anything, but my negative 6x's are pretty close. So if I just multiply one of these equations, like this second one here, by negative 1, I can get something that'll cancel. So this will now be a positive 6x, positive y, and this will equal a negative 4. Adding those together, cancel out those 6x's. Negative 5y plus y is negative 4y, and then 20 plus negative 4 is a 16. Dividing both sides by negative 4, I have y equals negative 4. Plugging that back in over here to get the x value, that's negative 6x minus negative 4 equals 4. This is really a plus 4 here. If I subtract 4 from both sides, I have negative 6x equals 0. And then dividing by negative 6, we have x equals, 0 divided by negative 6 is 0. Well, that's nice. So that's the point 0 comma negative 4, which is actually the very first letter here, letter S. Cross that off. And we've now got 2 questions left. For this system of equations, it looks at the beginning like we don't have both of these in standard form. The first equation, we've got letters on the left, number on the right. The second equation, not so much. But before we panic, it is worth noting that the letters are at least on the same side, and they're not on the same side as the number. So we actually do kind of have standard form over here on the right if I just reverse who's on which side. So I'm going to rewrite things down below here. We've got 7x minus y on one side, and then we can say that equals negative 2. So I literally just swapped who was on which side. Now if I do that, I notice that I've got these y's that are going to cancel when I add this together, so let me go ahead and do that. And then negative 3x plus 7x is 4x. Negative 2 and negative 2 adds up to negative 4. So dividing by 4, I have x equals negative 1. Let me plug that back in over here for the x next to the 7. So I've got negative 2 equals 7 times negative 1 minus y. So that's negative 7 over there. Adding 7 over to the left side, that's going to be negative 2 plus 7, which is 5. And if 5 equals negative y, dividing both sides by negative 1, I get y equals negative 5. So this is the point negative 1 comma negative 5. And is that any of these points down here? Right here, negative 1, negative 5, that's I. Let me cross that off. And it's on to the final question. For this last system of equations, they've saved the best for last here. Our first equation is not quite in standard form, although the second one is, so I guess it could be worse. So let me put this first equation in standard form. The 10x can stay where it is. I do need to move this 3y over to the left side by subtracting it, so negative 3y. And then this negative 5 needs to move over to the right side, so I'm going to add that over there, so positive 5. Now looking at my 2 equations, if I add these together right away, nothing's going to cancel. But if I multiply one of these, like this first equation, by negative 1, that's going to give me a positive 3y that'll cancel the negative 3y. It'll also give me a negative 10x, and then again that positive 3y that I wanted, and then 5 times negative 1 is negative 5. Adding those equations together, we cancel out those 3y's. 2x plus negative 10x is negative 8x. And then 1 plus negative 5, that's negative 4. Dividing both sides by negative 8 to get x by itself. That gives me negative 4 over negative 8, which I can reduce to 1 over 2. So it's not my favorite number to get necessarily, but we can work with it. There are worse fractions out there. So let me plug 1/2 back in for the x over here. This seems like a good place. So 10 times 1/2 minus 3y equals 5. 10 times 1/2, half of 10, that's just 5. Subtracting 5 from both sides, I get negative 3y equals 0, and this actually kind of makes up for having to deal with that fraction earlier, because 0 divided by this negative 3 just gives me a y value that is also 0. So we have 1/2 comma 0. 1/2 comma 0 is going to be right here, the second one here, so we can cross off the h. And now we're going to take a look at our letters and see what the answer to the puzzle is in just a moment. All right, so we've crossed off everything that we could. We've run out of questions. It's time to answer the question, what kind of shoes does a frog wear? So looking at my non-crossed off letters, I have an O, a P, an E, an N. Well, that spells open. That's probably one word. So let's go with open. And then maybe at the start of the next word, we have a T, O, A, D. Hey, that spells toad. What kind of shoes does a frog wear? Open-toed. Oh, I get it, because like a frog and a toad are kind of the same thing. All right, take it easy.